of the types of problems we've been doing where we have proportions, when we have a fraction equal to a fraction. It's just getting a little more complicated looking. Doesn't mean that it's a whole lot more complicated. You just have to add a couple steps to be able to get there. Then after we get done going over this, then we're going to introduce a new idea with similar triangles, and it really isn't new. It's new for the class and the book, but it's things that we did in our last unit in test prep where we have similar figures and we can create proportions from that. So it's going to take a little while to get through this, but we have a little bit more time since we didn't have to grade. We have a proportion here where we have two ratios equal to each other, but this time we have mixed numbers in there. What do we normally need to do with the mixed number value when we're dealing with multiplication and division? Chris? Change it to an improper fraction. Is that what you said, Dawson?
Yeah.
So I'm going to rewrite. I'm actually going to move this. See if I've got this. There we go. Move this up here. Give myself some room. I'm not going to do anything different with 4/9 and x because they're already in a simplified version. So 4/9 over x. But I am going to change 2 1/5 to 11/5, and then change 1 3/4 to 7/4. And I saw some of my pre-algebra, or the other pre-algebra students in the other hours trying to do some of these the other day, or yesterday, and when they were trying to multiply weird stuff, they were trying to multiply these two together and then multiply by the reciprocal, and make sure that you keep it simple. It's cross products. So your cross products are equal. So what I mean by that again, this is a product. We're going to take 11/5 times x. That's 11/5 x. And then we multiply these two. Don't try to do anything strange with it. Just multiply them. 4 times 7 is 28. 9 times 4 is 36. Now we have a problem that you should be familiar with. That's 2 strikes in 2 days. I'm going to get my phone to you.
Does that mean we can take over that too?
What's that?
Does that mean we can take over that too?
No, that means I take it away from myself. Okay. So looking at this part now, focusing in here. Bailey, how do we solve for x?
I don't know.
Divide.
Carlos?
Divide
Divide by what?
each other.
Reciprocal.
Okay, there's an order to it though. You can't just...
Or just across.
Can't see.
Never mind.
Can't see. Xavier, you said reciprocal?
Yeah.
Of which one?
3, 11, I meant 11 days.
Fifths. 1105?
Yeah, I was looking around at the bottom.
Okay. Oh, where it looks there. Yeah, so we want the reciprocal. This we're dividing by that, but that's the same thing as multiplying by the reciprocal.
Which would be 1, right?
Over on this side, yeah, we take 5 over 11,
Which would make it 1.
makes that 1, gives us the value of x. And then on the other side, I'm going to write it out for this problem. So it's 28 over 36 times 5 over 11. Okay.
So why don't
Multiplying by the reciprocal.
Why don't we just multiply 5 11 on first list?
You have to get those other two together first.
Or other two?
These two. But you don't have to show that stuff. You just go straight to that. Okay. Then will 11 reduce with 28 and 5?
Yes.
Yeah.
No.
No.
11 won't. Will 36 reduce with 28 or 5?
No.
Yes. They're both even numbers, aren't they? And I can take it a step farther. Will 4 go into both?
Yeah.
So 4 goes into 36 9 times, goes into 28 7 times. Now I can multiply. I just got a common factor. 4 goes into 28 and 36. Rather than divide by 2 and then divide by 2. I'm just shortening it up. And so x equals 35 over 99. And that is the answer because we can't reduce any more in here. So we're not going to be able to reduce down there. Okay. Here's where we get into the similar triangle aspect of things, which was on our ratios and proportions from our last unit. If two triangles have angles with equal measure, the triangles are similar. Similar figures are figures that have the exact same shape, they're just a different size. One might be bigger, one might be smaller. And in this case, looking at those values, Xavier,
Bigger was twice the size of the
the bigger triangle is twice the size of the other one because we can see that this length is 4 and the corresponding length, meaning the length that matches up with it in this particular shape,
Is 8.
the part that looks like it is 8. So what do you do to 4 to make it 8? You multiply by 2. So it's twice as big, and that works all the way around. 2 times 2 gives you 4. 3 times 2 gives you 6. And that's what this is saying at the bottom. Corresponding sides of similar triangles are proportional. Corresponding sides are the sides of the triangles that if you take this one and set it up over here, which ones match up? Lesson 70, a few lessons away, but on lesson 70, they're going to show you two triangles and they're going to twist them where they don't write them where they're lined up nice and neat. They're going to take one and twist it, and you're going to have to know which side matches up with the other side. And the way that you do that is you look at the angles. These are what we call tick marks that are put in here. And so I'm going to call them by angle 1 because there's one little tick mark there, angle 2, angle 3. Make sense? So here, angle 1 is opposite the length of angle 6. Here, angle 1 is opposite the angle or the length of the side that has a length of 3. The side that has a length of 3. And so those two sides are opposite the same angle, so they correspond. They match up. And it's easy to see on these because of the fact that the triangles are drawn out that way to begin with. Okay. But the sides opposite congruent angles are corresponding. Okay. So how does this work? Solve for x first here. Kelsey, if I'm solving for x, what length in the other triangle corresponds with x?
4.
4? Yes, 4 does. So I'm going to put x over 4 because they correspond. And then I'm going to put that equal to a pair of corresponding sides from each of the triangles that I know both lengths of. So looking at both triangles, which corresponding lengths do we know the measurements of?
2 and 3.
2 and 3? Does each of you agree with that? We have an actual length for both of those, so we're going to use those amounts. Now come back to you, Kelsey. Which one of those two numbers are we going to put across from x? The 2 or the 3?
2, 3.
the 3, and I'll explain why. Oop. It's going to be the 3 across from the x because it has to have some form of a relationship there. X is connected to 4, here to here, because they correspond. X is connected to 3 because it's from the same triangle. X doesn't have any relationship with 2, any connection with 2, because it's not a corresponding part, it's not from the same triangle. So that's why the x and the 2 end up being diagonal from each other, because you have to line the x up with the 4 and the 3, because it's connected to those. Then you could say the same thing about 2. 2 matches up with 4 because it's from the same triangle, matches up with 3 because it's from a corresponding part. So that's why we can do it. Could you write this equation or this proportion differently?
Yeah.
We could rewrite it by putting, you can look ahead, okay, these 2 are connected, so I could write x over 3 because they're related, they're from the same triangle, the same family there. And then that's going to be equal to the corresponding part that matches up with x is 4, and the corresponding part that matches up with 3 is 2. Each of these will give you the correct answer because the x and the 2 are diagonal each other on both of them. Okay. So there's more than one way to write these proportions. Now if we do arithmetic or our process or butterfly method, 2x equals 12, so x equals 6. So x is 6. Now let's clear this so we can do y. Y. Megan, which side does y correspond with in the other triangle? 5. So I'm going to have y over 5. And that's going to be equal to, Kate, what would that be equal to?
5.
Well, we already put 5 on bottom, so we're not going to be able to use 5.
What?
Now we have to go to the sides that we know both links of. I'll get to your question in a second.
4 and 6.
We can use 4 and 6. Since we have 6 now, we can use that. So is the 6 going to go with the y, or is the 4 going to go with the y?
6 is going to go with the y.
Why?
Because it's on the same triangle.
Exactly. So we could put 6 over 4. And then we do your butterfly. Dos, you have a question before we do the butterfly?
Oh, no, I got it.
Okay. So then we have 4y equals 5 times 6 is 30. Not adding, we're multiplying. And then divide by 4 or multiply by the reciprocal of that, whichever method it is you're doing, and then reduce 15 over 2. Leave your answer as an improper fraction. The back of the book might write it as a mixed number, and that's okay if you need to go to that point. Good job. I would have used the 3 and 2 again here. The 3 and the 2, but the 6 and the 4, we know those 2 links and they correspond, so that is perfectly fine. Okay. Find m to start with. So m over. Kenny, which length from the other triangle does m correspond with? 9. So I'm going to have m over 9. And then Caleb, which 2 links, which 2 corresponding links do we actually know the links of? Where we have a specific length for both of the corresponding parts.
7 and P.
Okay, they do correspond, but I don't know what that length is yet. So, and I've already got m. I've got one variable in this problem, so I don't want a second.
4.
So we're going to go with 5 and 4. Is the 5 going to go across from the m, Caleb, or is the 4 going to go across from the m?
5, 4.
The 4, why?
Because it's the same.
There you go. So it's 4 over 5. Okay. The 5 and the 9 are connected. 4 and the m are connected. Then you do your 5m equals 36 by doing your cross products. 5m, 4, 9 is 36. Divide by 5, m equals 36 over 5. Girls, you doing okay? All right. Oh, I need to do P on this one. Kennedy, what length does P correspond with? On the other triangle.
Like on the little one?
Okay, here's P, correct? What length in the other triangle does this correspond with? So if I take this and I put it here, which one does it match up with?
7.
Okay, so you have P over 7. And that's going to be equal to what, Carly? Which two sides do I know the lengths of? Which two corresponding sides do I know the lengths of?
4 and 5.
4 and 5. Where does the 4 go? Across from the P or across from the 7?
E.
Why?
I don't know.
Because it's from the same triangle. They're related. They have to be across from each other because they're connected. P is connected to 4 because it's from the same triangle. P is connected to 7 because it's a corresponding part. So it has to be that way. Okay. 5P equals 28. And so P equals 28 over 5.
How'd you get 28? Multiplied.
It's sweet to have shock collars. Shock collar number 21. All right. Mr. Wacky and I, well, I shouldn't say Mr. Well, yeah, Mr. Wacky and I, we were discussing, I'm trying to come up with a new game, a new form of dodgeball, but something different entirely.
With
And-
flip-flops.
With what?
Dude, that'd be awesome.
Flip-flops.
With flip-flops, sure.
That's like
But anyway, the way what I'm coming up with, and I'm hoping to have this in my mind and have a plan in check for next Tuesday's Trojan time. But it's called Storm in Normandy. Storm in Normandy. How many of you know the story of Normandy? I'm sure Mr. Wacky's talking to you about. Tell me. Can you tell me just briefly?
It's like back in the castles and stuff, right?
Well, no, that's true. Normandy is a part of that medieval time.
Yeah.
But what I'm talking about, Storm in Normandy, was World War II. Whenever the Allies stormed the beaches of Normandy and Omaha Beach. Now, are you with me?
D-Day.
Did anybody watch Saving Private Ryan?
Yep.
That is,
All the heads going off people's body.
yes. Yeah, unless you were really there. Then it wouldn't be so awesome. But anyway, that was Storm in Normandy, where they dropped people off of boats up by the beach. Guys had to swim through 18-foot water and get caught up on junk and stuff. And anyway, what I want to do is create a game where the mezzanine would be the top of the cliffs of Normandy Beach, and then the basketball court is going to be the beach. And so we'll have one group of people up here, the Germans up there, that will be fighting the Allies who are going to have space on the floor. Now here's the problem. I had to figure out how much space would proportion out with the cliff size and stuff like that. In the actual Normandy invasion, the cliffs were about 100 feet high. And then the beach, the flat part of the beach that they had to run across where they were just setting ducks with all these machine guns shooting down upon them, was about 200 yards. So you had 2 football fields worth of, no, it's 200 feet, sorry. It was about a football field, 200 feet. By the time they actually kind of got up into land. So imagine having to run a football field from one end of the football field to almost the other end with shotguns, bombs. You've got barbed wire, you've got obstacles, people are getting hit around you, people are screaming, and your goal is to run straight at that. Okay? Yes.
What you do if you're in that problem is you pick up a dead body and run.
Well, and I'm sure there was some of that as a shield.
Hold it over you.
If there was some small. But my question though was, in our game, how much room am I going to have here that will be legal to fire at people, fire at the Allies from the Germans up here? Well, so I went over and I measured how tall the mezzanine is to the floor, and that's 8 foot. Okay, so how could we find this length that I want to determine as a firing ground, or as create as the beach area? Chris, say it again.
A proportion.
Set up a proportion. We know that if I'm looking for x, I'm going to put x over what length in the Normandy scale here is actually lining up with the
200.
beach here. 200. So I'm going to go x over 200
And then 8 over 100
equals
8 over
8 over 100. Why am I putting 8 across from x?
because
it's with it.
100
It's with it. If I were to draw this on down to the part where the beach starts, and draw this on down to where the beach starts, I have similar triangles. And then that's what allows me to do this. So I do my cross products. I have 100 x equals 1600. Divide by 100. X equals 16 feet. So from the bleachers, base of the bleachers, out into the gym, 16 feet, will be the area where the Germans can just boom, boom, boom. Now they'll be fired back upon, but it's a lot easier to throw downward than it is to throw upward.
And the
aerodynamics.
Yeah. Now throw into this idea that the boats, whenever these U-boats were driving in, they were having to drive into a close enough range that they were being fired upon. And if you've seen Saving Private Ryan, you've seen that. Those gates dropped while the men were standing there, and they started unloading on them right there. I mean, people didn't even get off the boats before they were shot. But we're going to have an area here where it's water, and then this area here will be the safe zone.
Will there be medics?
Good question. Will there be medics? We'll have to consider
put
that.
them on scooters.
Probably,
Run over them.
you know, it'd be a good idea
Never.
is to allow the medics to. You can't shoot a medic
To swim
in the water area, but you could shoot them
on land.
on land because the Germans wouldn't have
What about that little fence?
not shot medics just because they were medics.
What about the fence thing with jigs on it?
Yeah, we won't. I won't be able to do that because we don't really have anything we can use.
Saying
You're just going to be good luck. And it may be a tank. It may not work at all. I don't know. But,
So we
Can
can
they
go
fire
across
back?
the water.
huh?
Can they fire back and then catch a ball?
Yes. It'll be a dodgeball type environment where you throw them back and forth. stuff.
Just make like giant dodgeball.
And then there'll be 3 sections
Have like a giant rubber band, just pull a bat.
of Germans, and there'll be an obstacle that the Allies are trying to hit that'll what's the word I want? Take out that unit or that group.
Eliminate.
Destroy what
That seems almost.
Oh, I got that recorded. That's good stuff. So, all right, your assignment. Problem set 65.
Going too fast, I don't know what you're
Do Monday.
You should. That'd be good. I wouldn't get down still.
Yeah, do next Friday, man.
Next Friday.
Next Friday, we're good.
Why don't you should cut the problems down?
Yeah, make it like 1 to 30 evenings.
Like only 15
Oh,
times.
Any more suggestions on what I assign will be 1 through 30 for sure. Okay? I am considering reducing it, but if anyone says something else about another idea that they think's better, then we'll just do 1 through 30.
So whatever we say is going to be the opposite, and you're going to do the opposite.
Mm-mm. That's not what it is. Let's do 10 through 30.
I told you.
And that will be due tomorrow, and I know we've still got about 15 minutes, 12 minutes of class. You may do the first 9 for extra credit. You may, yes, if you'd like to.
How much
Bailey?
extra credit would that be?
Oh, I need help on one.
It could be about, well, it depends on if there's multiple parts.
For the
1,
dodge.
2, there's 1 extra there. There'd be 5 extra credit points. So.
For that dodgeball thing, can we wear camo?
And this. I had a
I'm bringing my face paint.
but I don't know how to. I don't know if I
We
did
had
that.
face paint on last time. Remember that? Yeah. I got it in my eye. I didn't know you said that. Gross. We don't wear face paint.
That's supposed to say that. He has an automatic one back there. They own that.
Yeah. It's very good.
How much was Saving Private Ryan? I don't think it's even rated.
Traded R for pirates.
Are we gonna watch that movie in what's it called?
Return of the Titans or something like that.
Remember the time?
Yeah.
Maybe.
Can we finish it?
I don't know. I've actually got something else planned, but
We've seen every movie but that one. You wanna watch Money Talk? You know what I'm talking about?
I know that.
I know you talk. I want you to stop.
Maybe like there's this. They're like in a mental hospital, and like this guy cuts off, and you see blood. It's gross.
Well, that's Kelsey. Kelsey be laughing the entire time.
I was actually.
You guys were really very well during the class.
Have you seen that show?
But I do.
I see Clash of the Stick Wars.
Clash of the Stick.
problems done. There's some easy ones on there.